Hello, my name is Professor Colin Dwyer, PhD, and I'm here to teach you about the exciting world of geometry. Now, before we get into the really hard stuff, I gotta teach you the basics. B-A-S-I-K-S. Now, we got some really good stuff in the top right corner here, as you can see. These are lines, but being more specific, if you want me to, they're parallel lines. Now, you might be asking, what are parallel lines? That's a really bad question, but I'm going to tell you anyway. Parallel lines are when you've got two or more lines that never would touch, even if you extended them on forever and ever. Now, for this, I only drew two lines, one and then two, because I didn't want to confuse you by making like 3 or 4, because those are really high numbers. So that's what parallel lines are. You can tell that they're parallel lines by these two little lines that you draw, like sort of like an X that sort of cross them, That shows that they're parallel. Now this right here is a circle. Nobody really cares about the circle so far. They're pretty useless. I certainly don't care about them. We haven't done like pretty much anything with it, and I don't know if we ever will. But this right here, that's a triangle. Triangles are good, because they got 3 sides, 1, 2, 3, and they got 3 angles, 1, 2, 3, and they got the inside, the angles, the measurement of the inside angles have to add up to 180 degrees. Why that is, I don't know, but some suits in Washington probably came up with that one. Now this one's a square. Squares are pretty good, but a better word for a square is a parallelogram. Now this might get a little confusing, because all squares are parallelograms, but not all parallelograms are squares. Because right below it, you see I got another one. That's a parallelogram, but it's not a square because it's sort of got like a little slanted line and another slanted line. But if you really want to know the definition of a parallelogram, then I'm going to tell you right now. It's when the opposite sides of a 4-sided figure, 1, 2, 3, and then 4, when the opposite sides of the 4-sided figure, they have to be parallel. That's why it's called a parallelogram. And now these two right here, if you look at them, they're line segments. Line segments are different than lines because line segments don't, go on forever. Line segments are probably a little easier to understand because they don't go on forever. But this might get a little confusing right here because even though these two line segments don't touch, they're not parallel. And here's why. It's because if you extend it on forever, then they'll cross and they'll touch and they'll intersect, as they say. And for these two, you don't even have to do it forever. You just do it a little bit and then they cross. It's pretty good. But then these two line segments are parallel because if you extend them on forever, you go whoosh, whoosh, then they won't end up touching, because they're just so perfectly parallel. They're just, one will be like this, and the other will be like that, and they'll never end up touching. So, I think you're just about ready to get on to a little more advanced stuff. What I'm going to be teaching you up next are the 6 ways to prove that triangles are congruent. If you remember correctly, that's a triangle. The 3-sided one with the 3 angles. You'll probably figure it out. I certainly did, because I'm a doctor. Thank you. So, I'm back, and earlier when I said there were 6 ways to show that triangles are congruent, that was all a clever ruse that I created to keep you on your toes, because I gotta, make sure that you're paying attention. So in reality, there are only 5 ways to show that triangles are congruent. Here's my list. 1, 2, 3, 4, 5. 5 ways. I got side, angle, side. That's like it is what it is. It's when you have a side that's congruent, then you have an angle that's congruent, and then you have another side that's congruent. That means the triangles are congruent. And then the next one, angle, side angle, ASA. That's when you got an angle that's congruent. Then you got a side that's congruent, and then you got another angle that's congruent. So angle, side, angle. Then number 3 is angle, angle, side. This one's pretty confusing, so listen up. It's when you have an angle, and then you have another angle, and then you have a side that's congruent. So 2 angles and a side, except in the order angle, then side, not angle, side, then angle. And then number 4 is side, side, side. That's 3 sides, count them up. You can do it. I'm too confused. But we have 3. We have the first side, then the second side, and the third side. All have to be congruent to meet this. Now number 5, you're really gonna have to listen close, because this one's really hard. This one is called hypotenuse leg. It's when you have, in a right triangle, you have to have 90-degree angle, as you can see there, and then the side opposite to it is called the hypotenuse. That's a really long word, I get it. It's hard to remember, but you know, you'll get used to it. So it's got the hypotenuse, and then you have to have a leg. A leg is one of the other sides of the right triangle that isn't the hypotenuse. So you got the hypotenuse and the leg and the 90-degree angle. You can't usually have angle side side, that's why it's not on here. But you can in this case only. And instead of angle side side, it's called hypotenuse leg. Because like I said before, you have to have the hypotenuse and the leg. So it feels like you should be just about ready to get onto our proof. I think that you might be a little stunned at first at its difficulty, but I'll teach you how to do it because I'm a really good teacher, as you can probably assume from the last couple of minutes. Alright, let's get on to it. Let's go.